All right, ladies and gentlemen, this is Geekle. This is Node.js Global Summit 2025. I'm Ed Nadine, and as always at Geekle, we are starting our summit. We're starting this fun technology, community, innovations, insights, and all this stuff. So I'm super happy to welcome everyone here. And let me see what we got today. Let me probably read all these awesome topics we're gonna be discussing today. And yeah, we start with Roberto Bianchi in a few minutes with faster, simpler, service-oriented architecture in Node.js. Then I run code from the internet and automating cloud workloads with Node.js, Docker, and Cloud Run. Then we're gonna have break, and then two more speakers: Max Base with next gen microservice gateway real time forwarding with BAN, and why content, not just docs, needs more from open source community. That's what topics we are expecting today. And today is the second day of this summit because we had this AI day previously, and this time is more technology oriented, more node oriented or framework oriented day and talks, of course. What else? By the way, I want to show real quick with share real quick with you the uh, trick or yeah, just advise how you can get our here we go. How can you get all the um, recordings of previous day and previous days and this day of Node.js Global Summit, along with all other recordings from Geekle. Now it's super easy. We have this AI navigator where we store all our recordings. You can learn all these sessions. We add every week some more new fresh sessions, and it costs like super affordable subscription. And as you see, you can choose Node.js and learn all the Node.js related use cases and sessions. Most of them are AI related nowadays. So yeah, and let's move on. Also, I would love to share a bit about CTO Global Summit. So yeah, we never did it before. It's something new. We're gathering more than 1,000 CTOs and tech leaders and AI dev tool teams to discuss AI transformation. We have some brilliant speakers coming up, and they are preparing great talk. And I personally interview everyone to hear if they have real story you can learn from. So if you are the engineering manager or CTO, please go ahead and register to this event. But one thing, this is the invitation only event, so you can't just go and buy participation. You need to apply, and because uh, we trying to make sure this audience all are managers and the high level high net worth networking. So if you are not CTO, what I'm saying, if you are not CTO, just let your CTO know that this is happening, and ask him or her invite you with them. That's absolutely possible. So anyway, nice events ahead, but let's jump to Node.js Global Summit. So this is how it usually works, just reminding you that we have 3 speakers, then panel Q&A session where these speakers connect live and we discuss questions, and then we'll have break and um, more sessions and panel discussion. So yeah, later on we're gonna have Vue.js Global Summit and Software Architecture Global Summit and Flutter Global Summit, and as I mentioned, CTO. So that's my normal, usual routine of announcing everything that happens in Geekle with this community. And I guess now we gotta start listening to our first speaker. Let me just jump to agenda and announce our big friend, speaker who is with us actually for years, and this very high professional researcher, staff software engineer at Spendesk, Roberto Bianchi, and his topic: faster, simpler, service-oriented architecture in Node.js. Let's go down to this talk.
Hi everyone, I'm very happy today to be here at this Node.js Global Summit. So today we will talk about Node.js, service-oriented architectures, and an innovative approach to make this architecture faster and simpler. By the way, I'm working for Spendesk, which is a fintech European company. And yeah, since I gained a lot of experience during my career, I am able now to present to you some kind of pain points as of very good points about one kind of architectures versus another one. And what I will present to you today will be very interesting because it's a new open source tools that will allow you to get the best of both worlds. But yeah, let's jump directly into the microservice or service oriented approach. So let's talk about why they become so popular. As basically everything in the world, especially in computer science, there are usually pros and cons. So we will analyze both of them. We will try to understand a bit more about why microservices became so popular, and also what is the dark side, let's say, of a service-oriented architecture. And we will try to understand a bit more about them. So regarding the pros, for sure, one of the reasons for microservices to be so common nowadays is that they are solving not really, let's say, a technical issue, but more an organizational issue, especially in large companies, even, let's say, medium-sized companies. Team autonomy is becoming more and more and more important. Why? Because you want developers and especially teams to be able to own a specific service, or in some case own different microservices, and you want them to be able to autonomously deploy those services, debug those services easily, have a specific let's say unit business logic piece of code that is deployed somewhere and that they can own and maintain autonomously. So this will give us freedom, but especially and more importantly, teams will be more productive, because rather than pushing and deploying things on a monolith that is deployed all in once, you will have dedicated services that can be deployed at any time, of course, doing their own best to avoid the doing a breaking change to other services. Another reason is to allow services to be independent when scaling. For instance, you may have services that have a different kind of criticality, or they have, let's say, more importance or more traffic compared to other ones. For instance, in a company, you may have an auth service that serves basically all of the requests of the company in order for them to be secure, to authorize and authenticate them. And you may have a marketing service that track, gets, receive, and sends analytics events and try to understand them and maybe to push them to another kind of data ingestion tool. So as you can see, those two services are totally different. They serve for a different goal. In one case, the auth service is super important. It's critical for the company. It needs to be very fast. It needs to be always up and running. It probably requires a lot of memory and CPU because most of the requests require to pass through the service. While the marketing service, let's say, is not business critical. If this service goes down, the other parts of the service shouldn't go down. And especially, more important, you don't really care if it's a bit slow because it's just doing some kind of events or let's say analyzing events and marketing stuff, etc. So maybe you want for this service also to reduce the cost, so you accept for this service to be a bit slower. And so by having a service-oriented approach, you can achieve that kind of independent scaling more easily, because you can say, okay, for this specific service, I want to allocate this amount of memory, I want to have this kind of auto scale logic, and for this other service, I want to reduce the amount of CPU and memory needed. It's fine for me to accept some time, some kind of downtime, etc. So you can decide how to scale things in a more granular way. Well, when you have a monolith, it's way harder because maybe you have a piece of code that requires more resources from your machine, but you cannot say, okay, I want to allocate this specific memory to this specific function, for instance, or group of functions or module inside your monolith. You need to increase the overall memory of your whole system. And this can lead you to more cost in handling the whole and overall system. Another interesting part about a service-oriented approach is that you can achieve more easily a fault isolation. So this means that if a service goes down and other service doesn't require this specific service to maybe get some data, the overall system stays up and running, and only in this service and only the requests going through this service are failing. While in a monolith approach, if you have a piece of code that, for instance, has a memory leak and makes your process going out of memory, well, the whole system goes down, the whole system fails, the whole system returns failures to your users. So coming back to our previous example, if, for instance, we have a bug on the marketing service and this means that the service reached the out of memory issue, well, this service goes down, but the overall system stays up and running. While in the monolith approach, what you risk is that you have a bug in this service, it saturates the memory of your whole monolith process, and the whole monolith goes down, and then you fail to respond to all of your users. So this is another very good part about microservices. But what are some cons? Well, first of all, complexity, because you need to orchestrate very well requests across your network. You need to orchestrate deployments, when to deploy a new version of a specific service, when to roll back, avoid breaking changes, which, especially when communicating through APIs, couldn't be very easy. So it's so easy to do a change on your API that other services consume, and this change can be very easily a breaking change that breaks the contracts with other services, which means sending errors and failures to your final users. So handling the complexity in a microservice or service-oriented approach is not so easy. Another very important part is that you no longer communicate through function calls or maybe events inside your Node.js process, like in a monolithic approach, but you communicate through the network, which means that every time you need to require data or to send an action or to update something through the network, and you need to communicate through different services, you're going over the TCP stack, which means that you're passing through a cable, you're passing through internet, even though it's maybe an internal network that you define. But this introduces a latency, introduce an overhead, it introduces also some kind of potential failures since you're going over the network. And for instance, if you have for one specific request, you need to get data from 5 different services. Let's imagine that you have a super low latency of, I don't know, 20 milliseconds to respond in general for each service. Well, if you have 5 services, you will already introduce a latency of 100 milliseconds. And this is, let's say, already a best case scenario. So you need to be mindful of that, because there are companies that are running hundreds, if not thousands of microservices, and they require data from a lot of them. So handling the network latency is, again, not so easy. And another point is the costs, because of course you need to deploy way more stuff to your cloud provider or to whatever you use. So you have a dedicated amount of memory and resources for a pod or multiple pods related to one service. So rather than have one big chunk of code that is deployed that required some memory and CPU and resources from a set of machines, well, you need to handle multiple different containers, pods, whatever, that requires from you to handle more costs because you need to basically require more and more data and memory from those kind of services. So and also the fact that, as we said before, you introduce the network effect, so the network latency, this increase the amount of resources that you need to consume, because doing a TCP call require memory, especially from your Node.js process. So again, the amount of cost that you have only because you're doing network calls in between your services is going up. So what if we keep the advantages, especially in terms of flexibility of, let's say, a standalone service, so of a service-oriented approach, so having the flexibility of deploying them and being able to assign one team to a dedicated service and being able to, let's say, be autonomous on that, while we keep the simplicity of managing a monolith, which is for sure way easier to maintain, but at the same time it has the cons we mentioned before. And what if on top of that we add multi-threading on Node.js out of the box, so being able to run our Node.js process on multiple threads? We add metrics out of the box, so we are able to track how our Node.js process behave, especially under pressure. We introduce an API gateway, so we are able to, let's say, define some kind of routing rules for our internal services directly in Node.js. And we also add OpenAPI compatibility, documentation, being able to graphically see the endpoints of our application. Well, good news, we can do that nowadays with a very nice tool that I will present to you. And let's jump directly into it. So you can have a look at this website. So sorry, this GitHub repository, which is called VAD POC, proof of concept. So feel free to clone it if you want to test it. And as you can see here, I'm linking some kind of documentation from the Platformatic website, where you will be able to see the main features of VAD more in details. And you will also have access to the configuration parameters you can define, and that we defined here on the vad.json files. So as you can see here, we defined, for instance, the hostname and port of our application, the logger level, the amount of max YARN generation bytes that we want to define for our Node.js process, the metrics that we will see later on, the amount of workers that we want to define. So in this case, we want our application to run with 2 workers. What is the entry point of our app, and what are the services that are available in our app? So you can run it and follow those instructions. Let me also do that. So just, okay, so already started it. So I started from scratch. Then yeah, I can do this code. Had something already up and running. So let's wait for the message regarding Platformatic. Yeah, Platformatic is now listening at the port that we defined in our vad.json. And now let me copy it. Yep, I can successfully do calls to this, to the application. So coming back to our features, one of the main important one, I would say, is that we can avoid to go over the network. So we can make our service to communicate to each other through inter-process communication. So through Unix WebSockets rather than through the transfer control protocol, so through an HTTP or HTTPS protocol. And we can exchange data and send data through our services directly through inter-process communication. We will also see later on the benchmark about it, and they are super interesting because we will see the differences and we will compare how IPC versus TCP compares in terms of performances. Regarding multi-threading, we already seen so far that it's super easy. We can very easily add the amount of workers that we want, and our Node.js process will start with them. So it will split the traffic and route the traffic through that to the different workers without anything required from us. Another interesting feature is that we have access to the metrics. So again, looking at the vad.json, we can see that the metrics are exposed through the metrics endpoint on port 8008. So this one. And as you can see, if I update it and refresh it, the amount of values that I have here constantly change. And this means that I can also run a very nice tool that is called vadadmin that will get those metrics and render through a graphical UI interface. So let's also start this one. You can run this command that will start vadadmin on this port. Let's click on it. We can see that we have all of our services that we defined through the vad.json, the live memory, CPU, and event loop utilization, the amount of requests. And we can see here a more granular overview, not only of the different services, but also we can see the threads and the amount of memory, CPU, event loop utilization, latency, and amount of requests for every different thread. So we also have this kind of very nice overview. Then we do have an API gateway. It's not there is no setup for this repo to make the benchmarks more easily to run. So because if you have an API gateway, of course, the benchmarks will reflect the fact that you are also routing to your different services on top of this package, which is a Platformatic Composer. So since we run some benchmarks directly related to IPC versus TCP and HTTPS protocol, I just wanted to run them directly. But you can very easily define an API gateway in your Node.js VAT process using Platformatic Composer. Again, here you have the documentation about it. Basically, as we said before, it acts as an API gateway that you can define through a configuration that is, again, a JSON file. So once you install this package, which called the Platformatic Composer, and then you expose some kind of documentation and configuration about it, you can define, for instance, the IDs of your service, the URLs that you want to define, like in this case regarding OpenAPI, and a lot of other things that usually an API gateway allow you to do. So this is, again, a very nice feature. And finally, least but not least, we have the OpenAPI compatibility. So we not only being able to automatically see what is the JSON definition of our services. So as we can see here, it's written in OpenAPI schema. We have a definition for the check endpoint, then we have the other ones. But we can also see a Scalar UI about our service. And we can also do live calls to our service. Like in this case, if I run it, Value is false. False is coming from this query parameter. You can change it to true. And yes, it's updated. I can also do request to the IPC that we will see later on how it's done. The TCP one, we also have a response here, and the SSL one, so through HTTPS. Fine. So as we said before, I wanted to analyze the benchmarks and the differences in between the different kind of communicating through services. So we will analyze IPC, which is natively available running your Node.js services using VAT. And then we will analyze the same performances using TCP and SSL. So you can also do that on your own machine, running the test performance command. It will take some time. I already run it on my own. Of course, different results can happen depending on the amount of processes you are running in your background, the amount of memory you have in your system and whatever. But you will see that IPC communication will be way faster compared to the other ones. So looking at the test that we will do, as you can see here, so this is the endpoint we checked before. We run check all services. This function only run the request for every service, dump the body of the response, and checks if the status code is 200 or not. As you can see here, for the first one, so this is the IPC route, what we check here is a specific and spatial, let's say, URL, because in this case, the URL is created as a service ID as a placeholder, then PLT, which stands for platformatic.local, and VAT will automatically through the library called 11, which takes care of HTTP request call in Node.js. So VAT through 11 will take care of getting this spatial placeholder and converting to an IPC rather than going over the network. It will convert this call to an IPC1. It will go through Unix sockets, and it will allow our service to communicate directly through the inter-process communication. That's why you see this, let's say, spatial placeholder. While for TCP, we only basically start our services in a normal traditional way. So what we do is that, as you can also see from the package.json, when we start all services, we start VAT, which allows us to have IPC call, but we also want to run the benchmarks for TCP and SSL. So as you can see, we run directly specific server files. Okay, and in case of SSL, we run a clone of those files, but with the HTTPS mode enabled. If we have a look, for instance, at the Fastify one, we start, let's say, the HTTP normal one on the port 3001. And for SSL, we say, okay, let's define HTTPS through those configuration variables. So we get a private key and a certificate. And we return through the port 4001, okay? So in this case, as you can see, this was the TCP one, SSL one is on HTTPS. So this will allow us to run benchmarks for the three different kinds of communication. Why I also mentioned the HTTPS one? Well, because if you are leveraging a service-oriented approach and you are going over the network, to be more secure, you may at least require to communicate leveraging HTTPS. And in some cases, you also want to enhance the amount of security in between services, because if you are in a zero trust network policy, which some companies require, you may need to send an authorization header in between those requests. So again, that's why it's super nice and important to know that when you leverage an IPC, so inter-process communication call, you can completely avoid to go over the network. And this means that you can also avoid to have to sign every different request, because since you are not going over the network, there is no way to, let's say, intercept those kind of requests and to do bad stuff based on that. So Coming again back on the test performance, we can see that here we have the performance TS command. Let's also have a look about what it's doing, apart from some kind of formatting stuff. We're running autocannon depending on the different kind of communication that we want to run with the exact same parameters. So here again, we can see that we start the benchmark, we check the metrics for IPC, TCP, and SSL, and the result is it will be available if you run the test performance command on the logs folder. So let's also compare all of them. And as you can see, so first of all, we can see that the amount of successful requests when we run through our services through the IPC communication, it's way higher. Here we're almost at 4,000 requests that we run successfully through autocannon compared to 26,000 ones with that amount of failing requests. So we weren't able to complete those requests using TCP. And with SSL, since it's way more complicated because we are also adding on top of that a signature mechanism to encrypt the transmission of data through the TCP stack. So in this case, we have even less successful response and still a higher amount compared to TCP of failing requests. So this is very bad. Let's say compared on the same amount of memory and resources, since I run all of those tests on the same machine, you can see that, well, IPC have a way higher amount of requests that are successful. Also, the average latency is super interesting, as you can see. With SSL, we have more than 1 second in average, while with IPC, 250. And especially in the worst case scenario, let's say for also the average of the request, as you can see here, in this case, we can handle almost 4,000 requests per second with TCP less than 300, and with HTTPS around 1,000 requests. So again, this is super interesting to know. Same for the throughput, so the amount of bytes that we are able to process over, let's say, 1 second of activity. And same for the memory usage, the CPU usage. In this case, we need to consider that since we had so many failing requests, and that leverages a plugin called Under Pressure, which start to respond with 5 or 3 when you consume all of the, basically your event loop utilization goes too high. So in this case, to avoid the service to be completely unresponding, it starts to return 500 to the users, as we can see here. And so in this case, can reduce the amount of CPU and memory usage. But again, if we consider the fact that the percentage between successful and not successful requests, in this case, is super high, this will allow us to take a better decision on what kind of communication is better in this case. So yeah, that's basically all. Feel free again to have a look also at how to run those tests on your machine. And yeah, thanks a lot for listening to this conversation. I will also available for the Q&A session, so feel free to ask any question you may have regarding this approach. Feel free to follow my open source projects on GitHub. Here is the link. And same for LinkedIn, especially if you want to connect with me and see some updates about what I'm working on, what I'm doing. Feel free also to connect with me through LinkedIn. Thanks again a lot to you and to the organizer of this nice event, and see you there.
Thank you very much, Roberto. Very nice and deep talk, and thank you. I hope to see you at our Q&A session. And we're moving on. We're moving on, and let me introduce Zbigniew Tenerovich. I run code from the internet. Let's go.
Hello, let's talk about code security. Who am I to talk about it? Well, I have a bunch of experience with JavaScript. I'm organizing Meet.js and working on the project called LavaMoat, which is an open source tool for protecting you against your supply chain. And this is what we're going to talk about. And LavaMoat is being supported and funded by NMask, the wallet. So what gives me the opportunity to talk about JavaScript security? Other than my work, it's my long experience with JavaScript itself. So these are the first 5 lines of JavaScript I've ever written. Before I knew anything about JavaScript or security, I wrote this code, run it, and it would break Windows 98 up to XP before Service Pack 2 by destroying the Explorer exe process, which was not only the browser, but reminding you if you need to, also rendering the entire desktop, including the start bar and the windows and everything. So with that gone, you would be staring at an empty desktop. Not knowing anything about security back then, I concluded this program doesn't work and moved on. It was 25 years ago, by the way. Okay, but a bit after that, I looked at supply chain security a bunch, and these are topics that you can find on my website. So first, I looked at vulnerable dependencies and the audit scanners, NPM audit and the like, and the ability to safely ignore and make exceptions for specific vulnerabilities or packages without risking ignoring them in too many cases or opening yourself up to vulnerabilities. Then I looked at malicious install scripts, how they can be leveraged and how they can be stopped. Some content about that can also be found on my website. And LavaMoat allow scripts is the first tool in the LavaMoat toolbox that I found back then, which led me to get more involved with LavaMoat and exploring hardened JavaScript and defending from malicious packages at runtime. I also did workshops about defensive coding, which is a technique that you can use to make your code immune to product pollution. These were running on DEF CON, NodeConf.eu, and a bunch of other, including upcoming one on JS Nation this June. I also experimented with running malware, actual malware from NPM, and demonstrating what it does live. And all of that is available on my website. That being said, let's jump in. So this is a question I always ask people. And I know you can't raise your hands right now in a way that I would see, but let's vote in a chat and see who would trust me enough to take a string of text that I created and without reading, put it in their web application in production and let the users run it. Would you trust me that much? I'm waiting. Let me know. Okay. Well, would it help if I put it in a tar.gz file? Would it help? Well, because that's what NPM packages are. And don't get me wrong, they're great. They're really great. But at the same time, they're unsanitized input from people online you don't know that you download from the internet, put in your application without reading, and run in production, aren't there? Well, so what if some of those packages aren't great? Well, and I don't mean lousy packages. I made a bunch of lousy packages in my day and nothing bad happened. I mean malicious packages that intend to harm you or your users. What can you do about that? Well, let's look at it from a different angle. So backing up a little, all software architectures that we currently use in the web rely on what I want to call intention alignment. So an assumption that every author behind all code in your application has the same intention of building something with a shared goal of the application working and doing things for the user. And there's a growing number of authors involved in applications over time. So first, obviously, you and your team, that's a few people who can discuss what they want to do and work together. In a bigger organization, there's other teams. In every project nowadays, there's package authors, potentially about 1,000, maybe more of them, who created NPM packages that are being downloaded to your projects. And more recently, there's AI agents that are producing code and introducing risks on their own, but also introducing the risk of having different intentions than yourself, because who knows what their intentions are. I want to tell you that intention alignment is a myth. There was never a possibility of intention alignment between any authors in your code that would be complete. So, authors could publish malicious packages to NPM. Developers write buggy code. Developers misunderstand each other. You're definitely familiar with cases of a bug fix that you made or someone made in one corner of the application, breaking something unexpected on the opposite end. That's an example of a lack of intention alignment. Teams who work under different constraints or under different PMs, OKRs, they're going to have slightly different intentions. Now, switching to AI, AI famously hallucinates package names. This is called slop squatting. If you find this talk on my website, you can click the link and read more about slop squatting. AI code can also mess up some shared resources that other parts of the application need, or create a buggy polyfill for some function that you don't actually want it to polyfill. LLMs also are known to produce code that contains known popular ways of writing vulnerable code, because the internet is full of vulnerable code. So how do we solve alignment? That's a big question for the AI day, right? But alignment was always a problem with humans too. And we were trying to solve it with tradition, with law, with separation of powers. And in software, some examples of thinking about the alignment problem is the Conway's law that says that an organization is going to reproduce its communication structure in code. So if 2 bits of code are being maintained by 2 distant teams with bad communication, the communication between those 2 parts of code is also not going to be very close. Microservices is one of the ways to solve the problem of alignment, where different chunks of the application can be separate enough that they don't influence each other that much. And error boundaries and so on, these are all tweaks to our existing architectures that try to solve the alignment problem in humans. But the ultimate thing I want to bring up that is meant to solve the alignment problem, including cases where some of the authors of the code could be potentially malicious, is fearless cooperation. So fearless cooperation is the idea where we can build software in architectures and with tools that let us create logic that depends on logic from other authors without necessarily trusting those other people producing code. That sounds big. Yeah. It's been researched. There's a body of research about that. And if you want a quick introduction to fearless cooperation and the problems around that, you should look up Mark Miller. And also you can click the link, which leads you to a 15-minute fragment of a conversation where he explains the whole problem very well. And you can start your research there. Again, this is a clickable link. If you look at the presentation file on my website, you can follow that link. And today I want to tell you about a tool or a bunch of tools that help you bring about the world of fearless cooperation. So let's switch to a short story. Meet Dave. Dave is a software engineer. He is building an app, and he installs some dependencies. Meet Alice. Alice is a hacker. And Alice has a package that Dave happens to be installing without even knowing that he is installing it. It's somewhere deep in the dev dependencies. That's our setup. So what happens next? Well, Dave might think if he is not even aware of the package, how would he ever run it? So he doesn't worry about it too much. But that's not the best approach. So there's post-install scripts, and these can be used to run anything as the current user who run npm install in the project. In this case, Dave. Okay, so if Dave wants to care about this situation, he thinks a bit and comes up with a solution. Let's spin up a Docker container, run npm install in there, and then take node modules and copy them somewhere and then destroy the Docker container. That sounds like a great way to prevent install scripts from tampering with anything else around them, the project or the operating system, and stealing credentials and so on. So is that enough? Well, not really. So imagine there's an evil package containing a script that runs as a post-install script, identifies a location where TypeScript is, and creates a payload that it's going to then put in the compiled JS file of the TypeScript compiler, causing the TypeScript compiler to add malicious code to your application at compile time. And then the entire node modules is wrapped up, sent wherever you want to use it. The Docker container is destroyed. Okay, but this is not preventing this malicious package from working. Okay, so what can we do about that? Oh, by the way, if this example sounds oddly specific, that's because I actually made this package and it worked. You can find a talk where I demonstrate that on my website. So we can ignore scripts. That's great news. You can do that with a command line flag, but you don't have to remember to do it all the time. You can put that configuration in a file. And then, some of those scripts were there for a reason. So what do we do about that? Well, npm has a command that says npm rebuild. npm rebuild bcrypt is going to take the bcrypt package and rerun its install scripts to build the binaries that are actually necessary for bcrypt to work. All right. So here's Alice again. And Alice creates a bundled dependency in her evil package called bcrypt. And guess what? This gets installed, and the node modules folder inside of the tarball with the evil package is going to contain the files for bcrypt package, and npm is going to trust the package JSON inside to believe that this is called bcrypt. And now rebuilding bcrypt is going to rebuild both. That's too bad. Yeah, what now? Okay, LavaMoat. That's what now. So LavaMoat allows scripts. When you run setup, it's going to create npm rc or yarn rc that turns off scripts, and then it's going to generate an allow list that lets you select which of the dependencies are actually going to run. And for convenience, you can run installation and allow scripts to rerun the selected ones in one command, and that's it. So at this point, your installation process is protected, and it's literally a few minutes to set up, so please do. Every project that contains a package JSON file should be using this. All right, but that's not all. So let's get serious. Alice emails a maintainer of an old ESLint plugin, and says, I know you're probably fed up with maintaining this. Let me take over. I can do that work for you. All right. And now or thanks to a slop squat that someone uses, we get to an interesting place where Dave's program is actually running JavaScript from Alice's evil package during CI or production. So would you look at the code in your Node modules to spot this? Well, I asked that question a lot, and some individuals raise their hand and say, yes, we read our Node modules. Well, okay, would you spot this? This is a small chunk of a obfuscated version of what you just saw. It's a bit bigger. So without the ability to read it, the only way to prevent it is runtime. And there's an app for that. So the main tool in the LavaMoat toolbox is preventing malicious code from executing at runtime. How is it doing that? Well, we'll know in a moment. I could walk through how it's set up and what the policy file looks like and how you can add overrides to it, but instead, I'm going to show you. Let's look at this. So here's the policy override, but first, let's look at the application itself. Okay, so we have an application that has leftpad, the most famous NPM package, and it also depends on Cookie Monster. Don't go looking for it. I installed it from localhost, and Cookie Monster is a bit nasty. If we look at the content of that, the package is supposed to give you a random quote from a Cookie Monster, but being a Cookie Monster, he wants your cookies. So the package is also going to call fetch and send your host and your cookie information to example.com. Okay, that's not great. And the app itself is setting up some cookies so that we can see whether they're being stolen or not, logging them out, and then getting the random quote from the Cookie Monster, padding with left pad and a bunch of cookies, and then getting the reaction from the TypeScript file that I added here just to prove that this project is being built with Webpack and TypeScript also works. So this is our Webpack config, which contains the LavaMoat plugin and a bunch of settings. And then on the first run, we get the policy generated. So this is our dependency that has resources called globals. And we can see that there's document cookie, fetch, and location host. So the policy is being generated based on reading the code and figuring out these things are going to be necessary for this package to perform its entire functionality. At least it seems so. Okay, so these are the things we found when automatically browsing the code. But at runtime, you can make your own decisions what you want to do. So there's policy override, which is a file that is not being generated, but you can edit it manually. And in policy.json, every single package from your dependencies that uses any powerful APIs is going to be listed. In policy overrides, you can selectively make decisions about things. And in this case, we are forbidding all three globals from being used. Now, npm start, boom, we build it with Webpack, and let's take a look. So this is our application after applying policy. And as you can see, it throws an error. Fetch is not a function because we did not allow fetch for Cookie Monster, and the code from Cookie Monster index.js here is throwing this error. Okay, if that was not the case, let's look at the same application, but without LavaMoat protections. In that case, we would have our app console log the information, get a random quote from Cookie Monster. If we refresh, we're going to get a different one. You can see left pad working here and TypeScript and everything, and a 404 from example.com, where we were trying to send the cookies to. Okay, that's not very nice. So this is being prevented, okay? But I want to show you something more. So in policy override, we could allow fetch, build that again, and this time, fetch is going to work. We don't get an error that fetch is not defined, but as you can see, everything that we're sending is undefined. Why is that so? Because we are still not allowing document and location for Cookie Monster, and the code in Cookie Monster was trying to secretly read things from there, and it failed at that point. All right, moving on from here. Yeah, so there are two kinds of errors we can get from LavaMoat protecting us. One of them is about imports. So sometimes when you try to import something, you'll get an error. In this case, you're seeing an error from running a build under LavaMoat where an evil package was trying to request HTTPS. You can also get a cannot read properties of undefined. When someone was reading process.env, that's the kind of error you would get. And these are all errors that should not happen if everyone is behaving nicely, but if they're not, they will be stopped. Okay, there's one more thing that's going on in here that I want to show you, and it's a fairly new addition. So here, you've seen that fetch was actually available to the Cookie Monster, right? So in case your application has some vulnerabilities or something is added to it that doesn't run under LavaMoat, in case of applications running in the browser, what we're doing is we're destroying the entire global environment as much as possible. So the fetch that the Cookie Monster or the rest of the application is using is a copy of the reference to fetch. The original reference to the global fetch is being destroyed. So if I now try to fetch something, I'm also going to get an error. This is called scuttling mode, and it destroys every usable global in your window after everything has been wrapped in LavaMoat. Okay, and this is not visible here anywhere except for this little bit of config where the exceptions are soon not going to even be necessary here. Okay, moving on from that. Yeah, so at this point, Alice is surprised. I hope everyone else is also surprised. This is great. How do we stop that? How do we stop hackers at runtime? Let's take a short look inside. I'm not going to look at the code, but I'm going to tell you about the concept. So what does LavaMoat do at runtime? It puts every single dependency that you have in a separate compartment. I will define compartment in a second. It uses a policy to choose what to allow independently in each compartment, and it destroys all globals on the outside, as you have just seen. The whole thing is based on hardened JavaScript, which provides the secure environment for running our code. And hardened JavaScript consists of three main elements. One is the compartment, which provides scope isolation. So compartment lets you run code in a way that you can decide what the globals are going to be that are available to that code, and you can decide how it's going to import other modules. There's also lockdown, which is a feature that makes your realm in which you're running JavaScript secure. So it removes the ability to prototype, pollute JavaScript's built-in types like object, array, and get into places where you shouldn't by replacing the iterator functions, for example. And the last ingredient is harden, which is a function that lets you do what lockdown is doing to the environment to objects that you create yourself. So if you have an object that represents something powerful that the code can do, this is how you do it. You put it in harden, and you get a version that cannot be tampered with. All right, so let's again back out a little. What it seems is JavaScript, the way it's designed, is actually good for security. And if you think about it, the language itself is standardized in the ECMA consortium in a group called TC39. Meanwhile, the powerful capabilities that are available to the program are standardized in W3C and other organizations that standardize what the browser can do. And Node Core has its own capabilities, where someone also had to make up how that's done. Now, apply Conway's law that you've already heard about today, and you get the explanation why there's a good separation between the language itself and all of the powerful APIs, because any powerful API can only be reached through scope, so reaching to a global variable, or by importing something. And compartment controls both of those things, as in compartment controls how you can get references into your current scope. And that all comes with hardened JavaScript. It's eventually becoming part of the language. Parts of hardened JavaScript are being introduced, or prerequisites to hardened JavaScript are being introduced to the language right now. And in a while, we're going to get enough elements in the language to be able to build compartments out of those elements. For now, it's available as a shim. It's called SES. It's on NPM, and we're using that, and you can use it if you have similar needs. And SES, and hardened JavaScript in general, creates an environment for us where we can change the programming style a little, switching to object capability from identity-based security models. And that means code gets references to capable objects, and it does that instead of assuming it works on behalf of whoever is supposed to do that. And the object capability model is a security model that it was created with fearless cooperation in mind, and you already know how to use it, actually. So the whole difference is that instead of using what we call ambient authority, being able to get globally anywhere in your program access to all the powerful APIs, we remove all of those, and access to powerful APIs is given by passing references. So if you look at this example, we can have a linter that instead of using APIs available globally, it gets them passed in as references. In this case, we can pass only read file to the linter, and we know that this linter will not be able to write to our files, only read them and complain. Okay. Yes, I know that was a lot. So let's do a quick summary. Install time protections with allow scripts. This is step one. This is the gateway drug to LavaMoat. Then runtime protections with policy. You can have that applied to your Node.js programs. You can have that applied to your bundles through the Webpack plugin. And you can then run under hardened JavaScript with those. LavaMoat is protecting MetaMask, which has 30 million users or so, and it's protecting its installation, build time, and runtime with all those features. It's been doing that for almost 3 years, I think. Yeah, so this is where to go. And we're looking for more adoption and feedback so that we can improve it, we can make it more compatible with the ecosystem, and make it more applicable to everyone so that fearless cooperation can really happen out there in the world. Thank you. I'm looking forward to your messages if you're using LavaMoat for anything in particular, your production applications. If you want to get some help introducing it, feel free to contact me, and I might be able to help. Thank you.
Thank you very much. Thank you, Zbigniew, for LavaMoat and for this talk. And we're moving on. Kevin Yangu, automating cloud workloads with Node.js, Docker, and Cloud Run.
Hello and welcome everyone. My name is Kevin Yanogo and I'm a senior DevOps engineer at Click. Today, I'm excited to walk you through something practical and powerful. How can we automate cloud workloads using Node.js, Docker, and Google Cloud Run? Now, let's talk about automation for a second. We live in a fast-paced, hyper-connected world where time is one of our most valuable resources. Automation isn't just a trend, it's a necessity. We're seeing a massive push towards executing tasks more efficiently, cutting down repetitive manual work, and embracing smart, scalable solutions. Whether it's handling simple scripts or integrating AI to do the thinking for us, automation lets us scale up and innovate faster. Think about it. We've got AI tools everywhere now that help speed things up, from generating text to forecasting the weather or even organizing meetings. Automation is changing the way we live and work. Node.js is a great fit because it's lightweight, scalable, and perfect for scripting automations, big or small. Today, we're going to explore a use case that's both relatable and practical, building a newsfeed automation tool. Let's face it, we all consume news daily. But what if we could automatically grab the latest headlines, summarize them using AI, generate a nice Word document, and send it right to our inbox every morning? That's exactly what we're building, a Node.js powered news bot that automates this process end to end. So let's jump right in. Our goal here is simple. We want to script NBA news article, summarize them using OpenAI, compile everything into a Word document, and then email it to ourselves every day. And we're going to containerize the app with Docker and run it daily using Cloud Run on Google Cloud. Let's start by setting up the project. So first, we need to create the Node.js project by running npm init. This gives us our package.json file. Then we add a file named index.js, which is the main entry point of our app. Next up, we need to install all the packages we'll need. Express for the web server, Axios to make HTTP requests, Cheerio to parse HTML and script content, OpenAI for summaries, SendGrid for sending emails, and Docs for generating Word documents. After installing the dependencies, we can jump back to index.js and begin importing them all. Once importing all the packages or dependencies is done, the next step is to initialize an Express app and set the port to run to 3030. This pretty much lays the foundation for our service. And this wraps up the initial setup. Now let's move on to the fun part, web scraping. To fetch news content, I chose Sports Illustrated's NBA section as our source. I opened the site in Chrome, right-clicked and used the inspect tool to explore the HTML structure. And the goal here is to find the container that holds the top articles. So to do that, I scanned the DOM and identified a specific div wrapping several article tags. That's exactly what we need. So here we can see that we are trying to locate the ID of the field or the container that holds the NBA articles. And once we find that ID, we right click and we copy it. So here we have the ID, we have the container right here, the wrapper. So we can right click and copy the element. Once that is done, we can switch back to VS Code. Once we're back to VS Code, inside our express route, we can actually start by initializing the app. So once that is done and the app is initialized, then we go on to build our main function or main route. So inside that express route, we use Axios to fetch the HTML from the Sports Illustrated NBA page. We can see here that we are setting up through Axios, parsing the page using the ID that we fetched earlier from the page to identify the container. And after that is done, the next step would be to parse or to pass that HTML, that parse HTML into Cheerio, which will give us a jQuery style access to the DOM. To do that, we select the container we found earlier with the ID, and we loop through the first 10 articles. For each article, we're interested in two things: the title and the link to the full article. That's all we need at this stage, because next we're going to summarize each article using OpenAI. We will just provide the title and the URL to the article and ask OpenAI to go read the article on our behalf or for us and summarize it. So here we're saving the titles and links into a list. And this sums up pretty much this step. Then we move on to the next phase, which is summarizing the articles with OpenAI. Before calling the OpenAI API, I added the API key to a .env file or .n file. And we can add the API key value there for safety, and do the same also for the SendGrid API, since we'll use it later. And once the environment's variables are ready, we can switch back to VS Code and initialize the OpenAI clients using the key from the API file. Once the OpenAI agent is initialized, we can go back to the main function and loop over the list of headlines and links we just grabbed, and then pass each one into a custom summarize article function. Now, inside that summarize article function, we need to first build a friendly prompt that asks OpenAI to summarize the article in a professional but conversational tool, ideal for a news digest. And here we're using the OpenAI GPT-3.5 Turbo model that will give us clean and concise responses, exactly what we need. And then the next step would be to collect all the summaries that OpenAI returns and use them to generate our Word document. We can see here that we are building the OpenAI API call using the prompt as an argument. We'll remove the token size limits. Okay, and the next step would be to actually parse the response and save the value, return a list that contains the values of each response that was sent by OpenAI. This pretty much sums up this step, and our next step would be to create the Word document that will hold our news digest. One last thing would be to actually save each of the summaries in a list. Next step would be to generate Word documents. To do so, we write a function named createDocs. And the next step is to use the docs package. First, I defined the title and metadata and created a section containing a heading for Daily NBA News Digest. For each summary, we need to add the headline as a level 2 heading, a paragraph with the link, the summary text, and an horizontal separator to keep things neat. So once we added all these elements, after a few fine-tuning, we should have a pretty clean Word document that holds each of our summaries in a very clean and concise way. Each paragraph is well defined to keep the structure of the document neat and clean. So we create a new paragraph for the summaries and another one for the separators. And one last thing would be to actually trigger the docs file creation and select the name of our file for our file. This sums it up pretty much for this step. And the next step would be to send an email notification. Now that we have our summaries in a Word document, it's time to send it by email. So first of all, we need to set up environment variables. So one for the sender email and one for the recipient. We can create those environment variables in our .env file to keep things neat in our code. And then we create a function called send email with attachment, which reads the document file, encodes it in base 64, and attaches it to an email using SendGrid. SendGrid is very easy to set up. We won't cover it in this session, but they have a very comprehensive documentation that can get you started very quickly in how to set up a SMTP server with SendGrid and send emails. So here we can see that we are configuring the subject or email subject. We want to add a date to keep things neat and to be able to differentiate between different news articles or different emails. We create a try catch block to make sure that we can catch all exceptions. After wiring it all up, we need to update the main function to first generate the document and then send the document with the email attached. Everything looks good. It's time to test everything. In order to run the code, we run node index.js. And the code was cleaned up and a lot of console logs were added to keep the process, to help monitor the process. Here we can see that we have all the different outputs. Everything looks good. The code is running. We're generating the summary of each article successfully. Generate the Word document. Send an email successfully. And all done. So the next step is to check the inbox and see if we received the email. First of all, we can see here that our browser displays success message, telling us that the code run was successful. Next step, let's check the Gmail inbox. Here we see that we received the email with an attachment or document. And we can see that it's clean, well formatted, and easy to read. All the 10 articles are present. This pretty much sums up this step, and the next step would be to containerize the app using Docker. We first need to create a simple Docker file and make sure that the port specified is 3030. Also, one important thing to make sure is the version of Node.js. Here we're running version 22.14. And this pretty much should be enough. The Docker file setup is pretty straightforward. We can also create a Docker ignore file to keep our image lightweight and avoid uploading unnecessary models to the environment or to the registry. So next step, Cloud Run deployment and scheduling. So we need to go to Google Cloud and create an artifact registry to store our image. So here we set the name. Make sure you select Docker. Select a region. We'll choose US West 1. And that's pretty much it. Once the artifact registry is created, make sure you copy the path to your registry because it will be useful to build and push the image to the cloud registry. Here we build the image using Docker build. After a while, we see that the image was built successfully. And yes, let's add the Docker ignore file just to prevent adding unnecessary files to our container image. Let's rebuild. And here, after building successfully, the next step is to tag our Docker image using the path that we previously copied from artifact registry. Once everything is done, let's push the image. We see we have an error here. It is because we're not logged in. So after running gcloud.login, we should now be able to push the image to artifact registry. The image was pushed successfully. So after going back to artifact registry and reloading the page, we can see that we have our image here. This is beautiful. Now let's try to create a Docker service, a Cloud Run service. So here we see we have a few warnings. It's something that happens often when we're uploading to the cloud. So we create our Cloud Run service. Let's choose the name. Make sure we choose the same region, which is US West 1, Oregon. Here, make sure the port is the same as the one in our Docker file, which is 3030. Here, we will allow an authenticated calls or an authenticated access because we don't have any sensitive data. But please make sure that you require authentication if you have any type of sensitive data. That's pretty much it. Let's build our Cloud Run instance. Here we see that we have an error. This happens sometimes, and in that case, it's important to check the logs. After checking the logs and fixing, we can see that here we have a successful deployment. And actually, the cloud error was due to one of our environment variables. So this looks good. The next step would be to actually go to Cloud Scheduler and schedule our service to run every day. So first of all, we test the app's URL. We can see that the Cloud Run URL runs successfully, meaning that our application runs in the cloud. And we go to Cloud Scheduler and create a job. Let's choose a name for our Cloud Scheduler job. And while choosing the region, please make sure that you choose the same region as you chose while creating the artifact registry and the Cloud Run. And for the frequency, we will run our cron job every day at 9 a.m. For the zone, I am in Eastern time, so I will choose EST or EDT. So here we have the EDT time zone. And we can choose HTTP as the content and as the target, sorry. And paste the URL from Cloud Run. Here it's a get. It's a get method. So we can set the maximum number of attempts to 3 and create the Cloud Scheduler job. This is pretty much it. We have an automation that will run every day at 9 a.m. So this was a simple project that showed us how to build a NBA News Daily Digest. We built a fully automated production-grade workflow using Node.js, OpenAI, Docker, and Google Cloud. This is a great showcase of how modern tools can come together to solve real-world problems. Thank you for watching. Again, my name is Kevin Yanogo. It's been a pleasure sharing this with you. You can scan the QR code on the screen to access the full source code on GitHub, and feel free to connect with me on LinkedIn or GitHub as well. Thank you for watching and happy automating.
And yes, thank you. Thank you very much, Kevin. And ladies and gentlemen, we're moving to our Q&A session. I need just 30 seconds more and we'll come back to you just Yes, now I think I'm good to go and can't wait to meet in person or e-person our speakers. All right, speaking hello. Roberto, hello. How are you guys?
Hi, thank you.
Hi.
Great meeting you again, brothers.
Same here.
Yeah,
Let's
it's been fun.
yeah. Well, I guess you guys are both with us like for years, joining Node and other summits and sharing insights. And thank you very much for that. I appreciate that very much.
Thank you. It's a very nice event. So thanks for organizing it.
Thank
Sure.
you.
Yeah,
Thank you.
I've been watching and paying attention, and I think I submitted to the second one you ever did.
All right, great. And yeah, nowadays online events are smaller than at the beginning, but maybe you, Roberto, remember like thousands of people same time in stream, like that was crazy. Yeah, but well, thanks God there is no COVID or anything like that, and we can attend offline conference and uh, network in person. Anyway, let's get started with our questions. And first goes to you, Roberto. How would you recommend starting to adopt Node.js in a company? And what real benefits do you think it can bring to an organization? Yep.
Yeah,
And yeah, there is a continuation. Also, how can someone start contributing to Node.js itself? And how do you personally come up with new feature ideas or realize that something is missing? Apologies if it's slightly off topic. No, it's not off topic. Let's stick to the first part. Yeah, what about Node.js in company and what benefits? Nice question.
yeah.
I
Thank
guess.
you for asking. So I would say that first of all, to start adopting Node.js in a company, it's very important to study, learn, and master it. So starting basically from, I would say, a test project, so that you can get more used to it and understand more the pros and cons of using Node.js, because as every other technology in the world, it has pros and cons. It's very good for doing some kind of jobs and less good for others. So it's very important that you study and learn it. And also, it's very important, and this is what I usually do in companies when I want, for instance, to present a new tool. It's important to create a proof of concept for instance, a solution to a problem that the company has, and a technical idea on how this proof of concept can solve such kind of problem. So it's very important that if you want to use Node.js, you create maybe some kind of ideas, proof of concepts about how to use it in your company. And also start small. So I would not recommend, I would strongly discourage from doing a big migration of an existing project in production from one language to Node.js. I would suggest maybe to start from a smaller and new project, so from a greenfield. This is basically a way to reduce the amount of risks of using a new technology in your company. And regarding the real benefits, I would say one of the first one is the open source community around it is growing and growing. The number of downloads of Node.js is increasing every year, and there are lots of new packages available under the npm repository. So there is a great open source community, and you can start by studying and learning some of those packages and maybe start to learn how to better use them. And also another good benefit of Node.js is that it's full stack. So if you have a front end written in JavaScript, then you can use kind of the same language with of course some kind of differences to handle also the backend. And finally, it's great to handle concurrent connections, real-time applications, APIs. So if you have such kind of situation, it's great. Then coming to the second part of the questions about how to contribute to Node.js, again, I would say that it's very important that you start, first of all, by learning it a bit more extensively, and if possible, with some kind of hands-off and real experience in production. Maybe start from fix small bugs, improve the documentation first, read the documentation in deep, try things out, and especially try to build something you really need, because if you want to contribute the open source, you need to be really involved in it. You need to follow your projects and maybe people opening issues, pull requests. So it's very important that you create something that you or your company really needs. And regarding new feature ideas, I would say that it's super important. So to create a new feature or something that is missing, to monitor, first of all, what's going on in your company. So maybe identify some kind of pain points that you have in your company and some kind of ideas on how to solve them. Maybe you can bring those ideas to the open source world. This is actually what we have done in Spendesk. Also, try to look for some kind of tasks that you have to repeat every now and then. So maybe find ways to automate those tasks with, I don't know, a small npm package you can open source to the world. And finally, I would say that probably one of the best ways to have new ideas regarding creating an open source project or contributing to an existing open source project is to attend conferences and meetups like this one, because you can join different speakers with different ideas and presenting new tools. So you can basically learn new things and come up with new features ideas for your own project.
And
I can follow up a little on contributing if you don't mind. Because one thing that makes contributing to Node.js much easier is if you start by looking at the public conversations that are happening around the project, because everything being discussed is discussed in public on GitHub, but also there's working groups, and working groups meet online, and you can watch streams of those meetings and recordings later. In some cases, you can really get into the context of a working group, understand the problems they are facing, and maybe one of those problems is going to be interesting for you to solve, or they're talking about introducing new things, and these new things require a bunch of work around documentation, making examples for teaching those things. That's the easiest way to get involved if you don't have a specific need for a feature to introduce to Node.js that you know would be welcome upstream.
Thank you very much for this great question, whoever asked. And Yeah, one more question to you, Roberto. Have you used any other tools similar to Watt? Pros, cons.
So in general, I would say yes, not a similar tool, but something that accomplish something similar. So to have different kind of services interacting to each other. So most of the companies nowadays are using different Docker images and Kubernetes to handle all of them and to communicate between them. But as I suggested today, that is great because it's a new tool. It's creating something that doesn't existed before in Node, which is communicating in between services with a lot of great features on top of that. So metrics, IPC, so inter-process communication rather than going over the network, and a lot of other great features. So I would strongly recommend to try it out. I've also sent the link to the repo of the proof of concept I presented today during the demo. So feel free to check it out because, yeah, on the Node.js ecosystem, nothing exists in that terms. So a way to handle different services inside the same Node.js process using multi-threading. Google created a very interesting article about the technologies that could achieve something similar to that. And they created something like that with Go, if I recall correctly. I can maybe send a link to their white paper. But yeah, the concept is basically similar, but with another language. So yeah, I would strongly suggest to check it out. It's also very easy to run the setup and have it run it locally on your own machine.
Any take here, Zbyszek, maybe you? Or we're going to the next question.
I remember seeing the initial announcement of Watt by Platformatic folks, and it felt like magic. The performance benefit of running that is really great, and it's the ultimate way to build with like modules or services in mind, but without going into multiple Docker containers and building the entire infrastructure while your app is still small. It can have an architecture that's future proof, that's going to be reasonable in 2 years, while your startup, your product is still handling like 100 users.
All right, thank you very much. And next question goes to you, Zbyszek. What the strategy for dealing with false positives or unnecessary functionality flagged as suspicious in LavaMoat policies?
Okay, so there's two policy files. One is policy.json and the other is policy-override.json. The policy.json file is where LavaMoat generates the policy, and it attempts to generate a policy that lists everything that, based on static analysis of the code, including dependencies, seems to be needed for everything to work. So policy override is where the humans come in and put their rules. So policy JSON is going to change every time you add dependencies, every time you rearrange things. It's going to change slightly and will be regenerated so that you don't lose your decisions. They're in a separate file. And that separate file lets you either loosen or tighten the policy. So for some false positives, you can allow more things. So if we are not detecting that something is using fetch because the code was too obfuscated, sometimes for non-malicious reasons, that's also possible. Someone just minified their code too much. We then have to go to the policy override file and just say fetch true. Fetch access is granted to that specific package. So that's how you solve it. If you want to tighten the security, so you're using a package that has multiple functionalities, but you only use one of them, you can also manually decide to ban some of the more powerful APIs that this package should never need the way you use it.
Right, thank you very much. And going to the next one goes to Roberto. How do you handle service discovery and dynamic routing with IPC when IPC is used instead of traditional HTTP networking?
Yeah, this is actually the magic, as mentioned before, under the Platformatic VAT tool. So first of all, the contributors to VAT and Platformatic are people like Matteo Collina, which are one of the best core contributors to Node.js, and they know very well such kind of very deep technical topics. Regarding how it works, so how services can communicate through inter-process communication, basically VAT leverages an undici feature, which is also available in Fastify when you use the .inject method. So basically, it intercepts such kind of request to do a communication to another service, and it converts this kind of placeholder, which is your service name .plt .local, and it converts this to a Unix socket inter-process communication call. So basically, leveraging this undici feature to intercept communication with this method, it allows you to do inter-process communication rather than going over the network. And this is actually very useful. For instance, it's already used, for instance, when you do some kind of Fastify integration testing, because rather than starting a real server, you can do a fake HTTP call internally to your Fastify route. A similar mechanism leveraging the Undici library is used inside VAT.
Yes, thank you, Platformatic, let's say, right?
Yeah.
All right, and the next one goes to you, Zbigniew. In monorepos with internal packages, how do you manage and sync LavaMoat policies across multiple projects without conflicts?
The short answer is you don't. Let me explain
All right.
why. Okay, so if it's a monorepo with a bunch of packages in that, this is not the final destination of those packages. The packages get built, get published, and then get used in a project. So what you want to do is you want to use LavaMoat in the last step before going to production. And now, assuming this question was not about packages, but about a monorepo containing multiple services, or even in case of UI, some multiple UI apps, the idea is every single one of those has a separate scope of functionality that you're expecting. So every one of those should have a separate policy, because the idea of the policy is that we generate and tweak the policy, put it in place, and then if one of your dependencies suddenly becomes malicious and starts reading your environment variables and sending them somewhere, you want it to fail to read process env if it never needed it before, and you want it to fail getting access to fetch or the HTTP module. So that being said, every process you run, every single service you run needs to have a separate policy, because if they share a policy, the policy by definition has to give more general authority to parts of the application or the dependencies. So the smaller chunk you have, the more likely you are to also be able to comprehend the whole ecosystem of policies and tighten it even more. And using the fact that I already mentioned changes over time, and the question was related to managing the policy. We have some documentation on the LavaMoat website on how to manage your policy over time, and there's an article on how to review policy diffs, because the part that generates policy is generating with the assumption that the packages need things. And then you need to go through a step of reviewing that, because in the end, you're responsible for deciding what to allow and what not to allow. So we are not introducing decisions. We are listing things that the packages seem to need. And it's up to you to decide whether that result seems okay. And if you see a powerful capability show up in a package that shouldn't have it, like a package that generally just manipulates strings, suddenly has a requirement to import, let's say, a child process module. That's very suspicious. And instead of blocking it, you better look it up and see what the package is doing. So in that case, analyzing the policy is sort of an early signal that something goes wrong. And if the package manages to avoid getting detected that it's trying to use this module, that's where LavaMoat becomes really powerful and blocks it at runtime.
Great, thank you very much. Going to you, Roberto, and how to manage memory leaks or crashes in a single worker without taking down the whole system.
Yeah, so basically what happens when using VAT is that, as we have seen during the demo, you can run multiple processes on multiple threads. And therefore, if one thread because it consumes all of the memory, or it crashes, VAT will retry it multiple times. If I recall correctly, by default, it will retry 5 times. And otherwise it will completely stop this process. So of course, I mean, memory leaks are still possible. It's not a silver bullet that allows you to not have memory leaks, but at least they are, let's say, specific to one specific thread on a specific worker, and so it will not crash your whole system, but this specific process will go down. And of course, you need to have proper tools to debug and see your consumption live. And that's why I strongly recommend, if you test VAT, to also start VAT admin at the same time, because it will autonomously intercept all of the metrics from your VAT processes. And you will be able to see, for instance, if you have a specific process or a thread that is consuming more memory, or that is using too much event loop. So the event loop utilization percentage goes too high. So yeah, by using such kind of tools, you will also be able to properly and more easily debug what's going on in your VAT processes.
All right, thank you. And the last question will be to you, Zbigniew. How do LavaMoat protections interact with Webpack tree shaking or dynamic imports? Can this optimization possibly break policy assumptions?
So the way LavaMoat integrates with Webpack is by a Webpack plugin, and that's a very deep integration. And we rely on Webpack to resolve all of the files that end up in the bundle. And based on those resolutions, we also proceed to generate the policy and then process the policy. So the tree shaking mechanism is actually working in our favor, because the policy becomes more lightweight, because the tree shaking ends up, I want to say natively, applying to the policy as well. And there are some optimizations that we need to turn off, but that's not dynamic imports. earlier this year, I figured out how to handle dynamic imports, and the current published version of Webpack, I think, has all of that already. We have some more changes lined up, and we will publish a 1.0 sometime soon. But the current version is already pretty much done for 1.0. We're just not calling it 1.0 because there might be some small breaking changes potentially. One optimization that we had to disable is the one where multiple modules get inlined into one closure and they share a scope. And Webpack just pretends they're a separate module by making sure that variable names don't collide. But JavaScript is such a dynamic language that you could easily break out of what's possible in static analysis. And so we cannot allow that, and we are maintaining a separate scope, lexical scope, as in a function closure for each module, which is one of very many optimizations that Webpack is providing. So I wouldn't worry about that too much. It is making the bundle marginally larger by like a line or two for each of the modules you include.
That was it, actually. All questions from my side. And thank you very much again for joining this summit. Thank you, Zbigniew. Thank you, Roberto. Thank you for your expertise, your time, energy, and smiles. Not you, Roberto.
Thank you so much.
Now to you too. Okay, thank you very much,
Thank you.
guys. Thank
Thanks
you.
for
Bye-bye.
great questions.
Thank you for answers. Okay, dear audience, let me see what's next. Now we're gonna have 20, I guess, 20 or 20, even 25 minutes of break. And then we'll have two great sessions. So one from Cassian Ren, why content, not just docs, needs more from open source community. And another one from Max Bayes, next gen microservice gateways, real time forwarding with BON. And now we're going for break. Let's take some coffee, tea, lunch, whoever has something. See you in few. All right, that was break, and we're back, and we have one block left with 2 speakers more. Happy those guys who actually survived here in this stream, and we'll hear from Cassian. So let me introduce Cassian Ran. Why content? No, not just docs. Needs more from the open source community. Let's go.
This is Cassian Wren from NetApp. Hi, this is Cassian Wren from NetApp Instacluster, and I'm here to talk to you today about why content, not just documentation, needs a lot more love from the open source community. It's how content tells the story of a project and how steering that story is an important piece of your development of your open source project. I am an open source technology evangelist at NetApp Instacluster, and let's begin. First, a little bit more about me. I am agender. I use they, them pronouns. I've been in dev relations for a little over 11 years and dev of any kind for more than 16 years. I mostly write in JavaScript and Node.js, Rust, and I do a lot of web development. I have interests in WebAssembly, robotics, home automation, messaging systems, and search. And I am a cat dad to 3 lovely cats. 2 are pictured, Apollo and Asterion, left and right. They are not related, even though they very much look like they could be, but they are very much brothers. And I love my babies. So anyway, let's get to what we're here to talk about, which is content. So first, we're going to dive to what content is and what it does for open source projects. We're then going to talk about how it's made and who makes it. Why does content matter for your open source favorite projects, and how you can contribute to content, and how, if you're a project maintainer, you can steer content. So what is content? I kind of want you to hold a metaphor in your brain. Think of your project as a ship, and think of the content as the water. Now, you could be on dry land, not have any content. You could be in an ocean and have a ton of content that can, have waves and implications and things. So I want you to hold that metaphor in your head as we move forward, because I think that really kind of holds true for this. So content is a lot of things. It's really hard to define it. The easiest way I would define it is anything that anyone records and posts online about your open source project. So yeah, it's a lot of things. And another thing we're going to have to have as a running theme is the acceptance of you can control some forms of content, you cannot control other forms of content. And it can feel like a lot, and I'll show you why it can feel like a lot. So here's a very non-exhaustive list of examples. I'm not going to read this out point by point, but there's so much more to content than just documentation. There's release notes, just off the top of my head, there's Stack Overflow questions, there's blog posts, there's skeets, and there's so many things that you can do to create content on the web, Instagram posts, hashtags, anything that your company or your project writes. All of this becomes the content that makes up the body of work for your project. So if you ask me what the difference is between documentation and content, I would tell you that documentation is a subset of content, and that content can be lumped into 2 buckets. Internal content, which is the content that you as the project maintainers can control, and third-party content, which is content that you as a maintainer cannot control. So these have different little properties, basically. Internal tends to be posted on GitHub or the official website or blog for the project, etc. You also have full control here. As maintainers, you can code review, you can edit review, you can do all of these things. So you really have control over what goes there. These are usually looked to first for answers by users for questions, especially if you have good SEO and it shows up high in search rankings. But if users can find these things easily, these are usually the first things they look for. And that's a big caveat, if they can be found easily. And generally, hopefully, these are positive towards the project. These are things like, hey, this is a new feature we have, or hey, this is what we're this time much times faster than we used to be, etc. Third party is posted on a domain or platform that you don't have control over. Blue Sky, Instagram, Stack Overflow, Reddit, all of these. You have zero control over what, when, or where things get posted. And these things are usually Googled or searched with AI like ChatGPT frantically after internal content either doesn't fill the user's needs or can't easily be found. One of those two situations. And you have no idea if it's going to be positive or negative until you get your hands on it, unless the author happens to reach out to you first, which is rare, but can happen. So I guess, it's not for every single one, but you generally have no idea how content is going to lean, whether in terms of sentiment. So what does content do for an open source project? Well, if you think of the analogy, the metaphor that I brought up earlier with the boat and the water keeps the boat afloat, right? It gives away the boat a way to get from place to place. It gives the boat a way to, all these things. So it is good to have content for an open source project. The main reason I say content is important is because it's the story of your project. It's a record of the past, and it's usually pretty permanent because things on the internet tend to be pretty permanent. It's a record of the present, what's being worked on, what needs fixed, what needs writing, what needs doing. It's a glimpse into the multiple impossible intended futures, to-dos, Kanban boards, arguments on Discord, all these things. All of this forms what gets found when users search the web for your project. So the question becomes, what do you want them to see when they Google your project? Do you want them to see a lot of third-party negative content? Do you want them to see internal and third-party positive content? How do you want this to play out? So I think the pride versioning of semantics kind of comes into play here. You've got your proud version where you're proud of the release. You've got your default, which is just normal or okay. And then you've got your shame version when you're bumped to fixing things that you're too embarrassed to admit. And I thought that was pretty accurate here. So content creates an on-ramp for users and for contributors. So some content that I haven't mentioned yet that's internal are things like a contributing.md, a code of conduct.md. These are on-ramps for contributors. And for users, you have things like tutorials, documentation, blog posts, forums, Discord, Slack, a place for them to reach you out and talk to you as the maintainers. For contributors, there's a lot of content that goes into on-ramping a new maintainer to pretty much any project, especially of any complexity. So you have to take that into account when you're creating content, and you have to make sure that your contributing.md stays up to date and is treated as the living document that it is, as opposed to, So content helps grow and shape your community, and community helps grow and shape your content. So they have this relationship. Conference talks bring in folks that are interested in the technology. I also should put meetup talks here because those are great too. In person or virtual, they're a great place to meet people, network, and learn more about different technologies. Maintainers. Content turns users into maintainers when done well. So when your content, your on-ramp for a user is good enough that they not only learn how to use the tool, but how it works, that's when you turn users into contributors into maintainers. And it helps grow your user base because a happy user base brings positive content, and a unhappy user base either brings unhappy content or no content, and both of those are problems. So next we'll talk about how content is made and who exactly makes the content. So what happens when open source project launches a feature? Asterisk. This does not apply to open source projects maintained by paid engineers of a company. They're kind of a different animal. Think ones that are specially sponsored by a company and have paid engineers working on them. They're a little bit of a different beast. I'm talking about open source that is a project where the maintainers are not all paid by one company. Some of them may be paid, but not all of them. You've got a lot of people working in their free time here. So the hint is there's no common process for content that I've found in a lot of places. And that's not true of companies. In companies, when a feature gets released, you have your marketing department and you have the PMMs and you have product, and they all get together, and they get together at DevRel, and DevRel starts to write articles, and you've got all that. Internally here, you've got release notes, documentation, maybe a blog post, maybe a tutorial, and make changes to the docs and add tutorial as third-party content, fills in some of the gaps, and provides feedback. That last one isn't ideal. It doesn't always happen, but hey, sometimes. In the third-party world, the users piece together things with internal content and some headbanging. There are no perfect docs. There is no perfect set of documentation out there. So there is going to be some headbanging for those initial users. Then they'll start to write blog posts, tutorials, and post about the feature, and they use the feature and then provide feedback in the form of more content, be that tweets, Slack messages, etc. If you're lucky and you have an active community, you now have lots of content to pull on in order to create an on-ramp and a community that you can be proud of. You want to keep an eye on where your content comes from, because this is who is telling your story. There tends to be 3 buckets of people that contribute to content in an open source project. You've got your maintainers and contributors. These are people who actively, directly contribute to the project. They generally have positive things to say. They may have some feedback. They don't tend to produce as much content. They produce docs sometimes. They produce, sometimes they have a docs team. Sometimes the engineers do it themselves. It really depends. But they tend not to produce as much content externally. Internally, in form of GitHub issues, Slack and Discord chats, things like that, they may produce a lot of content, but a lot of external content doesn't get produced there. Then you've got your user bucket. They do a lot of third-party content. They are people who use the project for work or for fun. They may have contributed once or twice, but they're more just a user. It's generally positive, but the thing is that can change very quickly, as we've seen on the internet and the court of public opinion. And users produce a lot of content if the interest is there. The users love to put blog posts on their own blogs about technologies that they like. And so that can be really good for a project, especially for publicity and for getting eyeballs on the project, things like that. So companies use the project in their work. Some contribute directly, some don't. Generally positive. They tend to keep feedback to an internal channel rather than write a blog post with a bunch of feedback. It really depends on the company, but yeah. And they can produce a lot of content because they have people like me who are paid to produce that content. So who do you want your story to be told by is where you want to keep an eye on where your content comes from. If you need your maintainers to write more content or your users to write more content because you feel like 1 or 2 companies are kind of closing in, that's definitely something to keep in mind. So the content creation process is very broad because it's very different for each person, but I find there are 3 general steps. Someone discovers and uses the project for something. They really enjoy it, or they encounter some problems. Some give up here, but some go on to create content. When they create content, they write or record something about their experience, what they liked or they didn't, an issue that they had, certain problems, so on. That's generally how content ends up getting created, is someone uses something, they really enjoy it, or they encounter problems, and then they tend to write about their experience. If it's a problem, they'll write an issue. They'll write a tweet maybe or something, things like that, a LinkedIn post, who knows. So yeah. So there's this thing called radical acceptance, and it's the idea that you just need to accept the present as it is. And it's radical acceptance time for us. You can't control the content around your project. You can control the internal content, but you cannot control the third-party content. So that's why it's a bit like an ocean. A boat can't control the ocean. It can merely ride on it, right? That's not to say that the project can't be steered. It's like a boat. You could steer it. It's got a rudder or sails and things. You can control what you do to respond to third-party content. If it's good third-party content, or not good, but yes, good, but also positive content, you could repost it. You could post it on your blog. You could, share it, encourage your users to do more by doing these kinds of things. When you have feedback, you can respond with grace and kindness and say either we're working on it or here's our roadmap or something like that. You can take those things. You can respond to third-party content however you want, even though you can't control what's in the third-party content. You can put out more content to counter criticism and address feedback. That's not a problem. Just a few things to keep in mind when thinking about third-party content, though, that I've learned from many painful experiences. Filter out the non-constructive feedback and the personal attacks, etc. Just don't respond to it. Don't look at it. Just let it go. Take the constructive feedback seriously and respond with kindness and grace. And actually, work on the things that you get feedback for. And the third thing, and this is to me the most important, is to try not to take any of this too personally. It is, at the end of the day, an open source code project, and you, at the end of the day, are a human being. And so you need to take care of yourself. Or you could just ignore your third-party content. I wouldn't recommend this. I feel like it would lead to a situation much like in the picture here. I feel like interacting with your community is extremely important. And so, it's generally a good thing to not ignore the third-party content, or especially your internal content. So why does content matter for your open source favorite projects? Why does this matter? Why do I care about GitHub issues and LinkedIn posts and things like that? If you don't write your project story, someone else might. Your voice, your decision, your on-ramp will affect how people use and talk about your project. Eventually, they may not even contribute to you if you don't write any content. If you leave these to your community, you may not get back what you were hoping for, or you may just get no one using it. So you need an on-ramp. And no, not just documentation. You need a happy path that you can send a developer down in the amount of time they take for lunch, about 30 to 60 minutes, and have them working with your project. Tutorials, example config files, editor plugins, and autocomplete tools are all very handy in these situations. This is an observation. This is definitely not a scientific fact or anything, but I've found that if users cannot grasp something in the 30 to 60 minutes they take for lunch, they're likely to put the project down and not come back unless they're really, really interested. It's generally a very crowded space out there for tools. And so you really don't have a lot of time to actually, handle each and every one. So let's talk a little bit about how you can contribute to content and how you can steer content if you're a project contributor. Preparing to contribute to an open source project is a little straightforward. You look for 3 files: contributing.md, which is technically optional but preferred; codeofconduct.md, which is required for me but up to you; and a readme.md. It's worth a read because it contains usually most of the information. But we'll start with contributing. If you are a potential contributor and there is a contributing.md file in the project, read it. Maintainers, keep it updated and make sure it's a living document. The code of conduct. Everybody reads this one. If your project doesn't have it, I'm not working on it. But again, that's a personal decision that everyone is allowed to make to themselves. Just be professional adults to each other and take out the trash. The readme.md, if there's no contributing.md, this is usually where I go to look for a contributing like header or getting started with dev header, things like that. That's why I say contributing.md is optional. Some roll it into readme.md. And if the project doesn't have a readme.md, oh boy, I don't know where to start except looking at the code. So that's probably a brand spanking new project, or it's extremely underdocumented. So there are a lot of things you can do to contribute to a project's content, both internally and third party. You can work within GitHub and the docs for the project. You can contribute PRs, file and triage issues, mark good first issues, solve good first issues if you're new, commenting the code, or if you're a fan of not commenting the code and making the code more readable instead, then do that. Just, stick to the style guide in the contributing file and you'll be fine. For third-party content, really just telling your story of how you use the project tends to be a really great read for a lot of people, and it tends to teach people things like pitfalls to avoid. And these things tend to add to your on-ramp. You learn new things about how your product is run, what pitfalls that you can avoid, and you can assimilate those facts into your internal content. And that's what I mean by steering the ship. You can reinforce, positive posts that you like by sharing them and, getting them more views, and also getting more views of your project. Yeah, there's a lot of things you can do to contribute, even if it's just reposting something on LinkedIn about a project that you're interested in. You are contributing to the content of that project. So there's a lot of things you can do. Thank you very much for listening. I really appreciate your time. If you would like to contact me, my email is on the slide there. And thank you very, very much. Have a wonderful day. And hopefully I'll see you in the live Q&A.
Thank you, Cassian. And the time of live Q&A is right after one speaker, and I'm happy to invite the presentation of Sayed Ali Muhammad. Let me pull it up for you. It's next-gen microservice gateways. Real-time forwarding with BON. Let's go.
Hi everyone, next generation microservice gateway real-time forwarding with bounds. My name is Sayed Ali Muhammad. You can call me Max Mace. It's my pleasure to be part of Node.js Global Summit 2025. I'm a senior software engineer, OpenSummit and GitSubs. I'm programming over 10 years. My education background field is pure mathematics, and I'm trying to solve the problem by getting help from the computer science and combining to mathematics. You can find me on the GitSubs under Basemax username. We're going here to create a gateway forwarder for microservice architecture by getting help from TypeScript language and Bond compiler. So it is something new, and we are not going to use Express or Nest.js frameworks. We are going to just directly use just only one Bond without any third-party library or service. We are going to real-time create the gateway forwarders in TypeScript to show you how you can create a simple gateway in just 30 minutes. If you want to create a project, you can just type Bond in it, and it will create a project for you. And if you want to run a file in the project, you can just type Bond run index.ts. Why bonds? Because it is really quick and fast, and it is simple to run, and it is really quickly. Consider you want to create a project in Go or other compiler program language. It is something close to Bond performance. So if you want to create your server site in Bond, it is really good choice, and it will be really quick. How you can create a port and service easily? Just type bond.serve and pass the port, and you will have a fetch functions to serve the request as well. If you want to get more details from the request, you can just use request variables and get URLs, and then you can parse the URLs to get more things like method, URLs, headers. Consider you have a big project, about 800 API rows, and you have about 20 different sub-projects. Now you need the main central gateway to receive all the requests and split the request to the sub-project as well. So it is what we are going to do. We are going to create a central gateway to forward our request from one gateway to all sub-projects as a microservice architecture. We are going to create a config file in the JSON format. So here is the example and showcase for the config file we are going to handling and supporting the gateway. So here you can create some service with prefix or exactly path. Okay, let's start and do the projects. Okay, let's start the projects. I created the new directory. We need let's just spawn in it. It will create a new project for us. Index.ts. Okay, well. Okay, let's start. We need a type. It's fine. We need. Okay, we need a JSON file like config.json. And in the JSON file, we need to mention the structure of our gateway and forwardings. So let's create examples JSON file. Okay, as you can see here, we are defining the prefix mode and a path and method. So we are going to forward the method post of my logins to localhost port 5777, and we are going to forward our request that has a prefix users to localhost 8888. So it's going to be our config structures. Let's create the interface. For loading from the JSON files, we are going to use just bound files, which is a built-in ability in bounds to read file, and then we are parsing as a JSON contents. So it will be JavaScript object. After that, we can reading the debug mode, and default is the false. We are restoring some headers that we are going to remove before forwarding the request to the sub microservice. Okay, then we need the functions for forward request. We need to send the request to the forwarder by getting it from fetch library. It is a built-in library, so we don't need to export and add any library. Status, status text, and headers. Okay, it should be async functions because we need a wait. We are wants to return promise. Okay, good. Then we need the matching functions. We need to parse the URL. We do replace on the path names. We get the method. Okay, if we don't have any method, return true if it is multiply, so it is true. If it is type of strings, we need to match. If it is array, we need to map and to see if it included or not. Otherwise, we return false as well. After the functions, we need to use the functions. We need to get from the config exact match is active and as is exactly equal to path names and matching is true. And type of this return undefined. Okay, we need to define the config as well. So we need to load this one. We will do it later. Now we just need a function to start server. Port should be numbers, not a string. So we need the else. Okay, bad. Now we need to read the input. So we need a function for readings. We are going to use bounce in reader text decoder because it is bytes, not a string, so we need to decode it. It's similar to value. If the user type R, so we are going to again load the config. Well, and finally start server error.
And that was the end of this specific coding part. But we have Sayed Ali Mohammed with us. Hello, Max B. Hello, how are
Hi,
you?
how are you? Thank you. My pleasure to meet you again after a while.
Yes, absolutely. And that was incredible. Actually, I feel like you, brother, have like this mission to deliver lots of code to Geekle streams. You always deliver that much code, and I bet you want to explain actually what just happened. And please do share something additional to what we saw.
Yeah, sure. Let's me to present a screen. As you know, we are going to create a central gateway for a microservice architecture. So consider you have about 800 different API and you have about 20 different sub-projects. And every sub-project is hosting on a different server, on a different IP, on a different port. So now we are going to serve a central system to receive all the requests from end users and forward the request from central server to sub-project server. So it is like a gateway. The project we created is reading the JSON config files. In the JSON config file, we are defining the IP of the gateway server, the port of the gateway, debug mode, which we can enable to print a lot of information in the consoles. And we have a list of the service. I just added two service for examples. The first service is forwarding our request that starting with /user/ and it's forward. There is all of requests, all of URLs to localhost port 8888. So it's going to be, for example, forward user once, user anything, or maybe post user new or delete user blah, 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 blah. It will forward all of these URLs to this server and this port. So it is the purpose of the prefix methodology. The second examples is service examples which has the exact path. So we are going to only forward this path with post method to server localhost and port 6666. So it is the structure of the config file we generated. Let's back to the JavaScript code. We can run the projects. Let me to share entire screen. Okay, as you can see, I'm start the projects and it show configurations loaded. It started the gateway on port 7777 and debug mode is on. It's loaded to service. First is a prefix users and forwardings to localhost port 8888. The second one is a pass post, my logins and forwardings to localhost again 666. The reason we have host for every service is maybe each service is servings on the different virtual machines, different server, different VDS. So that is the main things for a gateway. And it is the software we designed is a minimal gateway which can be useful for a microservice architecture. So if you in your project or in your company you are following the microservice projects, it can be a good idea to create a smart and go to the points gateway for your projects. So it started the project on port 777, localhost 777. Okay, here is the path. I open the request. I can see the log live. Send another request like blah blah blah. I can see no match found, so it is 404 request. We even can see the HTTP codes. You can see 404. Let's to check the health routes. We designed the health routes in the code. Let's go back to the codes. We have a route health just to return a gateway is healthy and up. And the HTTP code is 200. Let's to test the first one, for example, /user. If you go to the /user, it will /user blah blah blah, like user delete. It will be show bad gateway, and we can see in the logs. The reason it's showing the bad gateway is fails to forwards to localhost port 888. You need to make sure your sub-service on the port, for example, 8888, are available to your gateway. At the moment, the sub-service doesn't exist, so it shows bad gateway, but anyway, the gateway is working well. It can be good because maybe your gateway is running well and is up, but your sub-service is down. So you need to handle the timeout problems, bad gateway, and it is the everything we handled so far in the project as well. So you can see how it's working. Also, we created a reloading features. If we go to the read stdin functions, you can see we are getting the stream from bonds, and we are reading the streams, converts into the strings, and then we check if comment is equal to R. We again update the config. So Consider your project is in the production, so you are not able to stop the gateway started again. It can be downtime for you. So it is a feature we designed in this tag to have a reload feature for the gateway, because gateway is very important. If your gateways go down, all of your company products and all services, consider we have 20 different services, everything will go down, which is not good. So it is why we designed a reload feature. If you type R and enters, it will be reload again, configuration reloaded. If you type something wrong and enter, it will be show unknown commands. So it is how the reload feature is working as well. If anyone has any questions, I'm happy to explain more about the gateway we designed.
Absolutely, we have questions. We have questions. But first question is from me today. You are really good at coding, right? But do you use any AI assistants? What did we see? Is it just ID suggestions inline, or you're using some kind of AI powered tools or whatever?
It depends. Like honestly, in my talk, I'm not using Copilot suggestions in more than 80% times, because it's suggesting something different to what I'm going to create in the talk. But generally, from this live codings, yes, I'm using AI, and that is fine. It's good to use the AI suggestions and AI response if you know what the code is doing. But the problem is, I can see in the new generations of developer, they are just copy paste things from the different things and runnings and go to the productions without understanding what is happening in the product. So I think that is a really, really bad problems, and it can affect on this learning curve. So they are creating project, they are delivering things, but they cannot learn. So it is really bad, because consider like 10 years ago when we started learnings and codings, we have to search a lot in the Google. We have to check maybe 10 different pages in Stack Overflow. So we have to read, we have to search, we have to maybe waste 1 hour, 2 hours just to look for some things. And that is the reasons we are learning something new. Because if you copy paste some things without understanding what is exactly happening, it's not a learnings. I mean, it can be really good and efficient from business side and the company perspective, or it can be really good and efficient for a senior software engineers. But consider you are a junior developer, you just started coding and you just started to learnings, and I think it can be really dangerous. It can be really bad
Yeah.
for the next generations.
All right, but well, AI is inevitable, right? So it's already here, and it gets smarter and smarter. And I sometimes even I like when I read some another news like OpenAI released the codex, the autonomous agent that code on your behalf. And anyway, it's here, right? So we can do that.
Yeah.
What would you suggest to your colleagues, especially of early days, how to actually not get drowned in this AI goodness or whatever?
For junior, I think they need to pay attention to when they need to use the AI and when not, because they need to learn, they need to read, they need to learn new things and practice. But let's ignore the junior for now. From the senior, I think it is really good and it's really great to use AI. Like in my real projects, sometimes I create a project like it is about 500 different lines, and at the end of the project, I'm sending all of my codes to AI. Okay, you are my seniors manager, you are my boss, you are my assistant. Please review all of my codes and let me know about 10 mistake IDs. And let me know about the mistake IDs or lines I can improve, or and you can see the result. It really works, and it is not always about asking the AI to do the project for me and wasting a lot of time for talking with AI for hours. Sometimes you can do your projects, or maybe you already did your projects. You can just send your project to the AI and asking, okay, you are my assistant, you are my senior boss. Please review the project and say me 10 problem in my projects. Tell me 5 where I can improve and fix the problems. And you can see the review, and it is something like you have a small brother who is next to you, and he can help you and say what is good in your code, what is bad in your code, and it is really good.
So what about actually pure vibe coding? Okay, if you are working on the old legacy projects, AI is not there to help you, right? But if you are starting some feature or microservice or whatever from the scratch, you could probably just vibe code it now, or AI is still not there yet.
Yeah, it is the new thing which is going to trends in nowadays, and it is really cool to create things without understandings. Where is the destination of the project? Just developing, adding the features to see what is the results. Yeah, it is really exciting to see such a things.
Yeah,
That
right,
you
right.
start to create, you know what you are going to create. For example, you are going to create a CLI tool for Git or some things, and you will start projects, adding feature, asking AI, please add 10 new features, please add 10 new features, please review the code and change the legacy code, please split my codes to a smaller function, a smaller piece, please modular my codes. And he is updating, and the final result is exciting because you don't know exactly what you are going to create, and it is really fun and cool.
Yes, absolutely. Let's jump to our question. I've prepared some for you. Okay,
Yeah.
so the first one would be something wrong. Yes. Can you see the question? Yeah. Could you
Yeah,
please
I
delete?
can see. So yet, what is your approach to loggings and debugging in production, especially without using Express Nest.js? Okay, in the gateway we designed, we are not using Express and Nest.js. So I'm not sure your question is exactly about the gateway designing, or is it generally about any kind of the Node.js or JavaScript project? But anyway, if your project is big, and you are not alone, and you have a team, you have like tens of different projects, you have front-end team, back-end teams, I think it is really good to use a logging systems like Sentry. If you search in the internet, you can see Sentry.io. I send the link in the chat, Sentry.io. It is like examples, monitoring performance, error tracking. It is not only about the loggings. Nowadays, they even connect the Sentry to GitHub issue, like to agile systems, for ticketing systems to monitor the issue in the local's internal team. So everything is not about the loggings, because like in the Sentry, you can monitor errors and understand how many times this error is going to happen in the recent days, in 2 days, and maybe you have common issue and error in the different project at the same time. So I think using the project like Sentry can be really good in this big project as well. Why not?
Absolutely. Let's jump to the next class. Next one. Please go ahead, read it, and answer.
How do you manage service discovery or health checks across 20 different subprojects in your gateway setups? Okay. In the minimal gateway we designed this talk, we just added a simple health for the gateways. So we don't have any health checkings for subprojects. But if you pay attention, when we use that fetch functions, when the sub-service is not available, we just showing the bad gateway to the end user. So we can understanding the sub-service is not available. So that is the good point. That is the good entry points to add a log to your system. You can send the emails to your DevOps engineers team. You can send the notifications to your Slack or different platforms, which you will quickly understand your service is not available and something is happening. It is something next to the monitoring system. Absolutely, as a production service, you have to have a monitoring service as well. But in the gateway, it is good to handle such as things when a sub-service is not available. But you have no any chance to do when a sub-service is not available. You cannot forward the request. You can just show error to end user. You can send a notification. You can send an email or message somewhere. It is
Right.
the only things we can do.
Right. Thank you. And the last one comes on the screen. Please go ahead.
If one sub-project crash or become unusable, how do we central gateway about cascading the future? It is exactly similar to the previous questions. If you integrate your gateway with Sentry, honestly, I exactly created the similar gateway next to ClickHouse database for savings all the requests next to the Sentry for a productions company in the reals. So I exactly followed the similar strategy to design the gateway for a real company and real projects. In that project, we had about 800 different API with over 20 different sub-projects. And I use that ClickHouse for storing all the HTTP calls, all the errors, all the requests, and number of the errors. Because ClickHouse is a SQL database, but it's really great for statistics. So you can easily see number of the clicks, number of the requests, number of the errors. It is not good to save all the requests in MySQL or other database because it is not a good database for that case. It is why we have other database like ClickHouse for storing all the clicks. It is the ClickHouse name is saying this is a database for clicks. You are going to store millions of the clicks. And exactly you can use ClickHouse and Sentry for storing all the crash reports in Sentry, and then you can report and monitor the problem there. But consider your sub-project is not available for 10 minutes. You can add a logic to your gateway to understanding this and stop sending requests to your gateway to save resource.
Right. Thank you very much. And
I hope
that was
yes.
I hope to. Thank you very much for your presentation, for your expertise and joining us and helping us with this event. Have a nice day.
Thank you so much.
All right. This is it, dear audience. Just to remind how to get those. Let me see how to get those recordings. Just a second. That's not the one. Here we go. Yes. So, as I mentioned earlier, we have this Geekle AI Navigator is the platform where all recordings are stored and accessible under the subscription. So you can come here, just choose the Node.js, and we'll be adding fresh use cases. Lots of them are UI-based use cases to Geekle AI Navigator every week. So yeah, we need anyway some time to process actually those recordings of today and upload there, but still you can find them over there, and the link is in the chat. All right, so ladies and gentlemen, we are done with Node.js Global Summit for today, and I hope you'll stay tuned to our socials, and we'll join to our next sessions, to our next events. Have a nice day, and yeah, bye bye.